everybody, Basket here. Welcome back to TIS-100. So I had some thoughts, and I was thinking about, which one was it? Okay, this one here. So the cycle count. I'm wondering if this is just how long the program is running. So I want to try something. This is a copy of the original one I had. And what I'm wondering is if maybe this is taking a little bit to run, and so I could potentially do this. So we'll see if this works. So I want to also move up to the right. So first one is going to go down. Next one's going to go over here. And then it's going to take turns. Each of these can run the code. So it's going to take it from the left. We'll see if this works. So the idea is that this program is more code and more nodes and stuff, but maybe it'll run faster because it's splitting up the job, possibly. So then take the thing, move it down. So we'll see if this works. And then this one is going to, because we need them in the right order. So we're going to first, this one's going to get the first thing. So we still want to do left, but the next one's going to be move up, down. And so it's also going to take turns. But maybe that'll be faster. Or not. We'll see. Run. Oh, okay, hold on. So it actually didn't like it. Interesting. Okay. Up, down, up, right. Take the thing. Oh wait. Oh, I'm sorry. Okay, so the first thing I need to. Oh, that doesn't work. This isn't the thing I was going to try. It doesn't work for this program. Never mind. How do I get out of this? Stop. How do I escape? There we go. Erase this program. Return to. Okay, so that didn't really work. So what I want to try is the same idea, but in a program where that actually is going to help. Which is not here. Okay, next. So how did he do it with this then? Why is mine so much more? Okay, let's go into this one. Let's think about this. So I'm taking the stuff. All right, let's try and do parallel. So it comes in here and we output down here. So if we want to have this adding happen, let's go here. So we'll try and split this up. We'll see if that actually helps out the timing. Is this a copy or is this the original? Wait, I want to edit the copy. So let's go back to here, copy. Now it's here. So let's take the same code. We're going to put it in those. We want to change this to just move up, down. And then here we want to take turns. So move up, down, move up, right. So this one happens first. It's going to take the thing, put it in there, increment it, and then move the thing to the right, which is good. So for this thing, first it needs to actually take left and put it down. And then it needs to go up and then to put it down. Okay, so this one's over here is going to take the one from the left. So I'm trying to make this one, both these things do the jobs. And while they're working on the code, the other one's also working on the code. So I'm hoping this will decrease the time. It'll obviously increase everything else. Okay, so then it does it and then it moves it down. So and this one does left first, correct? And then okay, so let's try it. So it does. It's going through all this stuff. All right, let's go fast. Okay. So in this case, aha. So that is what happened. So this is saying the node count. This must be just the general ranking. Okay, so doing this maneuver where I sort of split up the job, made it so that I was able to get to the same ranking that SP has on this. Okay, so that's the trick is the cycles is how long it takes to run. So for this particular program, I actually had more nodes and more instructions, but I had then lower cycles. And then this is just the top of, okay, interesting. So let's come back to this first one. We had a tie. So here I was higher on cycles. So let's make, right, so this is the one I was looking at. So let's actually erase this program. This is the copy. We want to return to the list. And then, so I guess we'll copy this to start with something. We're trying to get less cycles. So we can have as much code as we want. The trick is the output's here. So if I can do parallel, let me ponder how I will work this to, have sort of parallel processing where it's running more things at one time, like this code running in more spots. And then I will come back to you guys. Okay, so I have an idea. So right now I'm taking the value here, moving it over here, doing stuff, moving it down here, putting it there, spitting out. I want to sort of mirror this to be also on the other side. So I'm going to take these instructions. I'm going to, so the first one I do, I'm going to send it over to this side. And then the second one, I'm going to store it. I'm going to subtract the left, and then I'm going to move the thing down. And over here, I'm going to do the same thing that this one's doing second. So move up, right. This one I can just keep over there. The first time I'm going to move it over, but then the second time, I'm going to move up to the thing. I'm going to so take the thing from the top, move it into the storage, move the thing in the storage down. I think that's right. We'll see if I have to move it around the negate. Negate the thing, move it to the left. And then over here, so let's copy this line. So over here, I want to do the same thing I was already doing, but then I want to copy right and put it down. So it's possible that this will have more things, more code obviously, but maybe this will work. So run, maybe, cross your fingers. No, it didn't like that. Oh, okay. Cross your fingers. So this seems like it's working. Is this faster? We'll find out. I'll fast forward. Oh, still more cycles. Interesting. Okay. So let's return to the list. So that was actually more cycles than the original program. Huh. Okay, we'll have to think about that. What are some of the other ones? So that one we're good on. This one I have more on. Let's take a look at our program. So this one is take the thing, move it to the right. So everything is running in this one loop. How might I break that up some more? Goes out. So if in this one, okay, so let's go back to the list. We want to make a copy in case we screw up. So instead of, I'm going to have this one move over and this one move over. And then have them both move down. And then send it over here and over here. So these are going to be the things that are actually processing it. And then have them join back up. We'll see if that's any faster. Okay, so this one over here is going to be, the first thing it gets is going to be this thing over here. So, oh no, I'm sorry. We also need this value. That's complicated. So the value that comes in, if this is I remember this program. Okay, all right, let's ponder. So, so write A, if it's, okay, so we sort of are choosing what we're actually going to write. So that approach might not work too well because I have three values I'm kind of looking at. Yeah, okay, I changed my mind. I don't like this. Let's move on to a new one. Let's erase this. Yes. Okay. We want to go to the list. Let's just do a new one. Simple. Wait, what? Oh, that's weird. It already says nominal. Huh. Okay, anyway. So this is a program we have not seen. New program, go. So this one, we want to read from 1 through 4. Okay. Write the input numbers when the value goes from 0 to 1. 2 interrupts will never change in the same input cycle. So here's some examples. So for all zeros, 4, 3, 0. Oh, okay. All right. I think I'm understanding. So read them in, write the input number when the value goes, okay, and no 2 interrupts. Well, okay. So looking at these, they start with 0. Zeros, all zeros, nothing changed. So just say 0. This next time around, this one changed to a 1. So we say 4. This one changed. So it's compared to the last time. This one changed to a 3, or rather 3 turned into a 1. So we input this. Next one through, it's the exact same, so we say 0. So let's see. So the first thing we obviously need to do is we'll need to know what the last value was. So we will move up into the register across the board. Well, I'll just program 1 because they're all going to be kind of the same. So then we'll also want to reduce the number of nodes we use. So it kind of needs to transfer over and then down. Interesting. Okay, so we take the thing from the register. I guess it's always, it starts with 0 and then goes to, yeah, we'll see. Okay, so I'm assuming that the first 2 is always going to be zeros. So we take the thing and put it in the register. So the loop is kind of want to be if we take the value and put it in the register, we then can subtract the value. We don't want to save the value just in case. And then we want to subtract. If we take the value, subtract up. So by now we've already gone through 2 values at this point. We want to move up into the register. I feel like that's a good thing. We then want to, let me ponder this and I'll come back to you guys. Okay, I think I'm onto something. So first thing I want to do is take whatever's in the register. I'll explain this. This part's sort of planning ahead. So take whatever's in the register and then also replace it. So at this point here, both the register and the backup are whatever the number was before, and starting out at 0. Then I want to subtract the thing from above. If the value is 0, that means that the number didn't change. If it's fine, then I want to then I want to go back to the beginning. So if it's 0, then I don't need to do anything. Interesting, but I have to output a 0 if nothing has changed. So this won't quite work. Because I was thinking if I did that, then only whichever one was actually changed, it would output a value and I'd move it over. But if there's no... Okay. Okay, so we'll go back to that. So fine, that's what we'll go back to. So if it's 0, it's fine. Meaning there's no change. So let's move 0 to the right. For now, let's move it down. And I'll accumulate the things together. Okay, so if it's not fine, then there was a change. So then I want to move 1 in this case, and then move that down. And then jump to, or we can actually do the jump over thing. So we don't need start. Instead, it will just be jump RO2. So I believe that will then skip this, get to here, and then go back to the beginning. But the issue is that we need to get the original value back. Well, we need, I guess, we need to know what the last value was. So in this case, it's fine. There's no change. So we can just do, we can leave it because the back, we've saved it up here. So the first thing we did is we swapped out, like this thing makes it so that we take whatever's in back and we make both of these things equal to back. And then we did some subtraction stuff here. And so here we moved down the 0 and whatever was in back was also the value we received. But if that's not the case, then we need to do something here. So we need to get the opposite of this. So we need to, which is like an absolute value thing. That'd be nice. Okay, so back is not the value we want at this point. We want the opposite of that, and we no longer have whatever was up because we just used it for subtraction. We didn't actually keep it. So I guess what we can do is we can do swap. This is going to be a lot of commands. Swap. So now we have back in here. Well, okay, I guess at this point, if it isn't 0, it's either going to be 1 or -1. So we can say if it is greater than 0, so if it's a 1, then we need to make we need to jump to 1. So we want to make it, if it's greater than 1, let's see, so then math is, if it is 0, then they were the same. There wasn't a change. So 1, 1, there's no change. If it's -1, oh, my brain, it's hurting. So at this point here, we sent down a 1 to say it changed. If this, what's in our hand, is greater than 0, it means that the original value we had last, so the new value that came in was 0. Otherwise, it was 1. So we want to move 1 into the thing. And then we want to skip over some amount of stuff. I mean, really, we want to go back to just start. So maybe that's going to be easier. So then after we put 1 back in the thing, we want to save, because we want back to be equal to the original value. And I might optimize this in a second. So this is essentially, oh, I'm out of space. Okay, hold on. I always like to add in extra new lines, but so 0. So in this case, we want to move 0 into the thing and then save. And then jump to start. So both of these two things we want to jump to start. So save. There's a reason why I need to do that. Maybe instead what I can do is first swap and then save. So it's setting them both to that. Can I change that so I don't need to swap? I get, because I only need to swap in this last case down here. Otherwise, I just need to keep what is currently in my hand. Let's see if this works. So in this case, I'm going to set. So at the end of the program, it needs to have the ACK, the register of the ACK, whatever this is actually called, needs to be the desired value. So let's jump here to start. Jump, start. So whatever's in your hand is the last value. So in this case here, fine. So this is in what's in my hand is not the right thing. So we actually need to okay, I understand. So we actually here we should do a save. And then here we need to do a swap. So what this is going to do is, because at this point back via the save is the last value. Okay. With all that's being said, and this is all going down, right? Down. Put a 1 down. Put a 0 down. Okay. So let's do that for all these. This is going to be sending a 2 down. 3, 4. Okay. And now, so the value comes down. Now I need to figure out, this is going to use up a lot of space. Maybe I'll try and figure out how to optimize this later, but I just want it to work first. So we need to figure out, I guess I sort of want to send all these values to the right. I need to figure out which one is the highest one, and then keep that and send it down. Okay, I'm going to ponder that some more, and I'll come back to you.